Lesson 3-2, Scientific Notation. In this lesson, we are going to talk about how numbers can be represented in a different way. This is normally reserved, using scientific notation, for really large numbers or really small, but we'll be looking at all sorts just to do some practice and understand exactly what we're talking about. So scientific notation is a shorthand way to write numbers using a power of 10. So the first thing to know is that scientific notation has two parts. The first part is a number that is either equal to or greater than 1 and less than 10. So it can't be less than 1, but it can be exactly 1. Usually it isn't, but it could be. And it has to be less than 10. So it could be 9.9999, but it needs to be less than 10. The second part of scientific notation is a power of 10, like 10 to the first power, 10 to the second power, 10 to the third power, and you could go as, infinitely, 10 to the millionth power, 10 to the so on. Okay? So, when we have a number that's bigger than 10 or bigger, what we would need to do is move the decimal so that the first and second digits are straddling that decimal to create a number that fits this definition. So if I had the number 25 million, I would need to put a decimal between the first two digits to make it fit the definition of scientific notation has a number between 1 and 10. Okay, so here I've done that. I've put a decimal between the 2 and the 5. The second part of scientific notation is a power of 10. So how do you know what power to put here? Very simply, when you put the decimal here, how many places are behind it, behind that decimal? And we have the 5, we have these 3 zeros, and we have these 3 zeros, so that's a total of 7. So we have 2.5 times 10 to the 7th. This is scientific notation. This is the way to write 25 million in scientific notation. Now please notice the power of the 10 does not necessarily equal the number of zeros in the problem. That's a very commonly made mistake, so don't be caught and make that silly mistake. Now, what if you have a number already in scientific notation and they want you to write it in what you would call standard form or normal? Okay, so there's a couple of ways you could do it. Number one, you could just multiply it out. If you had 3 75 hundredths, 3.75, and you had 10 times 10 to the 8th, you could actually say, well, 10 to the 8th power would be 100 million, and 3.75 times 100 million would be 375 million. Or you could move the decimal point, the number of places the exponent is. Okay, since we had 3.75 times 10 to the 8th, that means we're going to move it 8 times. So it was sitting right here between the 3 and the 7, and we would go 1, 2, 3, 4, 5, 6, 7, 8. And then each of those spots that were blank, we have filled in with a 0. You need to be sure that you're neat when you're doing your little hopping, if you're going to draw the little hopping, because sometimes people have a tendency to make them very narrow, and then they can't count how many zeros to add. Here is one last way you could possibly do it. This is one I would call a shortcut. you would subtract the number of decimal places from the exponent and then add that many decimals. So our exponent is 8. The number in front has 2 decimal places. So we do 8 minus 2. So the exponent minus the number of decimal places in the first number equals 6. And so what we're going to do is we're going to keep the 3, the 7, the 5, and add 6 zeros. So that would be the shortcut way. All right, time for some practice.